Hello.
जी
Good afternoon to all. Myself, Dr. Vidyakant Shukla from IERT Allahabad. Now I am going to introduce the Professor Subodh Wariya, sir. Professor Wariya is a professor of electronics and communication in the Institute of Engineering and Technology, Lucknow. He has done his PhD from Motilal Nehru National Institute of Technology, Allahabad. He has more than 27 years of experience in teaching and research. He has published more than 100 papers. In the field of science and technology, his contribution make him a bright star. Now, I would like to request Professor Subodh Beria, sir, to come.
Thank you, sir.
Thanks, sir.
Thank you. This is the some summary or closing end of this very innovative and fruitful faculty development program on a very large and very attractive area comprise of five event. First is known as digital aspect and innovative modeling technique. Second is miniature, and third and fourth is electronic device, and last is circuit. The application of some say the our miniature or nanotechnology and application in electronics engineering. So today our topic is now changed or modified as some in introductory concept of MEMS and digital design in VLSI application. Okay. Uh, this is the outline of the electronics engineering background. The electronic engineering background device as modeling may be divided into the following category. As you know, the basic is analog electronics, having the devices integrated circuits means IC design. VLSI technology is means some fabrication by using some semiconductor material and design. Now the today is a digitization based on digital electronic design, having some logic design, synthesis architecture, microprocessor, and microcontroller. This and last is the embedded system design. Okay, because time is very short. So I skip one by one the mathematical modeling or some design aspect, having some basic concept of mathematics, having some concept of differential equation, coding, programming languages. Means in a digital design we having two type of languages. This is known as hardware description language as VSDL, Verilog, and etc. Some today computer science concept is data structure, designing your system, some operating system. Now we are the time of some emerging trend like everybody is says AI, uh, machine learning, neural networks, fuzzy logic, and some application of sensors for the data processing is a concept of new is known as IoT. So now machine learning, deep learning, data analytics, and blockchain. These are the emerging trends because our topic is comprises with the basic application of our electronic or nano devices in the field of mechanical, electrical, electronics, biomedical, biotechnology, automobile, automation, and robotics or 3D printing like this. Okay. See, now the concept of the analysis and design. Design means synthesis because we use some system, and so first we say ki find out the analysis, and second part is the design part. So the basic fundamental or conventional diagram says if input is known and system is known and we determine the output parameter, this is known as analysis. Now, synthesis means input is known and output is also known. You design your system as per your requirement, as per your requirement in terms of your system parameters, some your advantage or some basic need. Okay, this is the basic diagram which differentiate what is the difference between the analysis and synthesis. Now, today is the era of digital design concept. So some basic of design, digital design, historical perspective of digital design, circuit classification of digital design, quality metrics of this are the classification. Okay, for the programmable logic, digital device and technology. For example, this is known as because today is some ready-made solution is available in the form of chip. We know this is known as PLDs, programmable logic devices. So now the classification of programmable logic devices as PROM, logic chip, complex programmable logic devices, field programmable gate array, ASIC. Now PAL, PROM, this is the some architecture of advanced digital design. This is known as PROM, or PROM is a programmable read-only memory. Okay, and this is a basic function you can design with the help of PLDs. Now this is a basic concept of some PROM. Okay, this is the some design with advanced design with the concept of PLA and PROM, and you know if some input is programmed or some input is fixed. Program means this is the connection or no connection, or in a technical language, connection means the circuit is connected, or if the circuit is no connection means no input or no output. So this is some example of PLA. Okay. So this is the some basic classification. For example, basic of digital system. This is the overview. This is the digital system. This is the discrete system. This is the continuous system. Is known as an analog system. Now, digital system is described by the Boolean algebra. Or you can say the basic operator is defined in terms of gate, NAND gate, OR gate, NOT gate. This is the logic operation. This is the switch is connected or non-connected, switch is closed, switch is open. Now this is the AND function, OR function. This is a truth table. This is some example how to define your output with respect to input. So now this is a some gate level architecture. First is define the symbol of digital logic gate, and or NAND or NOT, or is known as inverter. Okay. So this is the some basic classification, the basic architecture. This is the 2-bit adder is known as half-bit adder is scheme. This is a full adder design. This is all the graphical representation of circuit is known as schematic. Okay. So this is a circuit having some inputs and you will get output according to your logic operation. The parameter of this digital design may be defined in terms of fan in, fan out, or you having some logic operations based on some assumptions. So this is waveform because in a digital design you have no system for checking your output. Only the graphical representation is available, and as per your logic to table you verify your output waveform. If all combination is okay, you will get this is the perfect input output system and function is okay. This is some block representation. This is the two block, two label design. This is a single block. Two half adder is used to design a full adder, and this is a full adder block. This is known as entity, and this adder, the block representation uh, is used to well-defined functions. Okay, one side is input and other side is output. Okay. Now, so for example, this is a some digital circuit classification. This is the basic review. You know, this is the combinational logic design, and other is the sequential logic design. in combinational logic, output is depend upon the input design. Okay, means there is no feedback system and there is no memory element. But in the sequential circuit, we have some memory element. This is known as flip-flop or latch, and so output is depend upon the present input and passed out. Okay, and this is the now in a in a digital system. First, we use in an old system is BJT, and other we use some MOS, and the latest is we use CMOS. This is a component level designing. For the now as classification of CMOS design may be static, may be dynamic. So static CMOS gate is a combination of two networks. This is the basic. Everybody is know, but this is some review concept of digital design or application of your some circuit by using some CMOS or MOS concept. Okay, this is the classification of logic families, or some logic family means the conventional design is using CMOS, plus digital family or classification or some modification is based on some number of transistors or number of components or power consumption, speed, fan in, fan out. These are the simple classification. As the classification means some component is used by and some component is suppressed or eliminated. The most advanced digital system design in a CMOS, we use a single pass transistor logic. This is known as PT, pass transistor logic, which attempt to reduce the number of transistors, and the gate is a control input. Okay. Now, this is the advanced digital system design. We use some logic expression. This is the control input voltage, and the output is a some input, and this control input. So this is the some overview of dynamic logic design. This is the basic architecture, a basic definition. Okay. So your PDN, your circuit is a sandwich between the N and PN transistor, and this is input is controlled by the clock. So we have two major phases. One is pre-charge and other is evaluation. So these are the some basic definitions. Okay, and the quality metrics of the digital design means how we select this design is best. So this is based on some cost of integrated circuit, functionality and robustness, performance, power and energy consumptions. And performance is important for the computer server. Energy consumption is a domain matrix for all cell phone. Today's scenario is a some uh, application is maximum and the size is minimum. uh, for the beginning, we have some mainframes, main computer. Now computer is reduced to a laptop. Laptop is reduced to a some tablet, and tablet is reduced to a palm top. And your mobile phone having all the functions like a multimedia functions, and the storage capacity in terms of terahertz, and the display is more. So you integrate all your functions in a single device, and the condition is size is minimum and battery life is maximum. So this is our trend. So this is known as technology. Technology means we reduce our component. We reduce the size of component, so you can place more and more component on a single chip. So this is the some cost of an IC based on some formula. This is known as fixed cost. This is known as cost per IC. This is the variable cost. Variable cost depend upon the material cost, assembly cost, and testing cost. Sorry. Now, this is the another functionality, and robustness is defined with respect to noise source in digital system. Okay. The measured behavior of the manufactured gate normally deviated from the expected response device. So this is the some definition. Now this is the some conventional analysis for determine the noise margin and noise voltage output, VTC voltage transfer characteristics. Okay, this is the some basic graphs is available in all the literatures. Now, this is the some definition of logic 1, logic 0. This is a regenerative property. This is known the hysteresis curve. Okay, this is the noise immunity. So the definition says noise margin express the capability of the circuit to overpower a noise source. So now noise immunity expresses the ability of the system to produce and transmit information correctly in the presence of noise. Okay. So these are the definition. This is the directivity. This the main concept is fan in, fan out in the electrical engineering is known as loading effect. Okay. How many gate or how many input is connected to a single gate. So this is the some standard or some conventional method, or this is known as gate input tally ratio. Gate the your hardware cost is depend upon the gate input tally ratio is minimum, means number of gate divided by number of input or output. Okay. Now this is the performance parameter is simple defined in terms of propagation delay through the logic, means time to get data in and out of the registers. So this is the now delay definition is depend upon the some 50% delay. TPHL and TPHL means high to low and low to high. This is a some graphical representation of delay having the rise time, fall time, delay time 10% to 90%. Okay, these are all the conventional. Power energy consumption is depend upon the power supply capacity, battery lifetime, supply line sizing, packaging. These all the important parameter is considered when we use the power consumption of the design determines. Now you know the coding requirement, different power dissipation measurement are the depend upon the these are the some formula is used to determine your power, the power having the dynamic power, static power, leakage power. Okay, these are the some formula or some literature available in the literature books. The important parameter in the advanced digital design is the optimization parameter is power delay product. Means some your circuit having the power is maximum per delay is minimum. Some circuit having the power is minimum per delay is maximum. So we use a power delay product, means optimization the device. This device is satisfied our requirement. Now, this PDP is a very important parameter. It is the energy consumed by the gate per switching event and can be used as a quality measure of the switching device. Okay. So these are the performance parameter or quality metrics or circuit classification. Okay. Now these are the three parameters. So they start with is VLSI, and last second is VLSI methodology or technology. VLSI technology is related to the fabrication. Fabrication means we use a different type of material and we use a different type of fabrication process. Okay. Now VLSI start, and today hot topic is MEMS. Okay. So this now as per no VLSI, the abbreviation is start as very large scale integration circuit. Okay. Circuits is defined as a fundamental component is connected by some input-output connection. And we having the two type of circuit. One is known as discrete circuit and other is integrated circuit. Discrete circuit component are connected by a wire on a breadboard or PCB design. The complete circuit is fabricated on a single substrate, is known as wafer, and this is also known as monolithic integrated circuit. Okay, the level of integration can measure in the by the following parameters, means number of transistor per chip or feature size. Why VLSI? Because VLSI is a integration improves the your design, and we use the design space, or we can accommodate more and more module on a same chip. Okay, or we know by the integration, and by we use some simulation software. The advantage is low power consumption, physical size is smaller, means some millimeter to some micro is to nano, means 10 is to power 3, means reduce in size. If the MOS device size is reduced in a micro to nano, so we can accommodate 1,000 of MOS on a single same area of wafer. Wafer is a size of piece of semiconductor. Okay, so we can design by using some wafer. Okay, integration reduce the manufacturing cost, almost no manual assembly. All the assembly, designing, software analysis is based on some software. Okay, we in the integration we reduce our parasitic capacitance, so speed is higher. Now, the important introduction to VLSI technology or design, the introduction means the father of VLSI is known as Moore. So Moore's law says that the transistor size is doubled for the every 18 months, and this Moore's law is applicable up to 2020 to 22. And the application is based on some application, cost of fabrication, technology background. We having some doping IC technology, MOS transistor fabrication technology, and CMOS technology. Okay, now this is some definition. VLSI application. VLSI application is defined by some Gazaki Y chart. Y chart having the 3 dimension. Okay, the application, as you know, this is the microprocessor, microcontroller, memory, DRAM, SM, special purpose processor. Now application is specific integrated circuit design as ASIC, DSP processor, embedded system, some optical switches like this. Okay, now Gordon Morse is the co-founder of Intel, and is the father of VLSI. The definition is says the prediction, based on prediction, means transistor density, because VLSI is you can accommodate more and more transistor on a single chip. The number of transistor per chip would be growth exponentially double every 18 months. Okay, so this is the some definition. Now this is the cost of fabrication. uh, Now the we this because time is very short. मुझे जो भी टाइम मिला है, मुझे 2.5 या 4 घंटे की बजाय 1 घंटे का मिला है, तो आप मेरी स्पीड और मेरे कॉन्फिडेंस को समझ सकते होंगे कि मैं कैसे उसको करूंगा. ओके, तो मुझे केवल आपको स्क्रीन दिखाने को बोला गया है. So this is some VLSI design methodology. You know, the number of transistor chip is increasing at exponentially rate over the last 40 years. So we use some automation by using some software. So this is known as CAD tool. Okay, computer aided design tool is known as CAD tool, and the development of technology is reduced, means this is known as CMOS technology, and CMOS is the MOS, and this is based on the length of channel. So development of technology means now we use a nanometer, 22 nanometer, 40 nanometer, 64 nanometer. CMOS technology means channel length is 22 nanometer. Now there is a various method is adopted by using this known as chip design, some fabrication, some packaging. We used a various packaging design style. When This is known as testing and testability. This is known as fall uh, tolerance. Our very senior professor, Professor H.N. Karsar from MNIT Allahabad or Prayagraj give a very important and fruitful lecture on fault detection in digital system, because designing is a one part and the testing is the other part. Okay, the mega issue is the design cycle is time. Okay, as per the VLSI design methodology, means we having the some ready-made solution of your system. This is no so there is a basically two design methodology are being used. One is known as full custom and other is semi custom. Full custom means there is a some fixed design ICs are available. Semi custom means some ready-made ICs are available and you can use this IC with additional gate and other subsystem. You will design your system as per your need. Okay, so now circuit, so we, so this is the full custom IC. The definition is says geometrical and the placement of every transistor can be optimized individually. The silent feature is required more time until design maturity can be reached. Low power dissipation, high speed, low area. Okay, the semi-custom is a based on some block level design, or there is a some ready-made semi solution is available. The, these ICs are available, and you can design your own system with help of this design with additional system. So this the some silent feature is require shorter design time. Initially, it seems performance is better because standard cell are being already optimized, having less chance of performance improvement. This design style is an important concept in the advanced VLSI design or digital design. For example, in a digital design is a very useful design, because if you have a three input, but in the design part one input may be absorbed and may be eliminated, and you will get a minimum number of output with using input. So some there is a some technique or some mechanism. For example, if a some standard block is known as multiplexer, okay, so or decoder in a digital design. For example, 60 cos 1 means 16 input, 1 output multiplexer is available. And you say कि design, but you say कि design a 4 cos 1 multiplexer. Okay, that means two input instead of four input. So that means two input is absorbed in your system by some manipulation. Okay, this is a very interesting design. Now, this is the design style classification of the design style for a VLSI product. Depend upon the performance requirement, technology used, expected lifetime of the product, cost of product. Okay. This is the design style. Again, we define some definition or some uh, concept, maybe depend upon the regularity, modularity, and locality. So some definition is available in the literature. Has regularity means some hierarchical decomposition of a large system should result not only simple but some also similar block as much as possible. Means we use some a standard block, and we this block can be used to design your system. Modularity means various functions block that make up the last system must have well-defined function and interface. Okay, hence each block can be designed independently. Okay, so this as similarly as locality. Now, the design quality or some testing and testability depend upon the some manufacturing, some fault tolerance, or some fault detection technique, reliability, technology updatability. For example, if you buy a one system or one laptop, and you say your this is a 8 GB RAM, and this RAM is extendable to the 32 GB. So this is your system is upgrade with the new technology. So you have both option. Your system cannot be say कि this is the obsolete system. Okay. Now this is the testability definition technology. This is the design quality. So this is the some design reliability means your system is reliable means, but this reliability is depend upon the some. So this is the some VLSI methodology means type of ICs, full custom, semi custom, design methodology, design constraint. Okay. Now today this is the main topic or main issue is known as MEMS. Now concept is MEMS is it because your FDP topic is based on miniaturization of electronic device. Okay, so electromechanical system. This is the most advanced. Now there is the some outline fundamental of MEMS, functional element of MEMS, some fabrication sensors like this. Now definition is first we define MEMS. Okay, what is MEMS? Micro electromechanical system is the integration of mechanical elements, or is a technology that is most general form can be defined as a miniaturized mechanical and electromechanical element, device and structure. Okay. So again, we say this is the integration of mechanical, electrical sensors, actuators, and electronic on a common silicon substrate through micro fabrication technology. This is the latest technology when we move from the micro technology to the nanotechnology. Okay, so this is the because today the application of nanotechnology in the field of automobile automation and robotics, because all the mechanical item is used by you using the concept of MEMS, some biomedical signal processing, biomedical applications, biotechnology applications, optical sensors, or biomedical equipments are based on this activity. Okay. The critical physical dimension of the MEM device can be vary from well below 1 micron to the lower end of the dimension. This is the some graphical representation of your dimension. What is the thickness of your system? For example, the height of man, human is 1 meter. Your hand is 10 centimeter. This is the your hair is 100 micrometer. Red blood cell, E coil, HIV, and this is the hemoglobin. Okay, this is the lower end dimension spectrum. For this is the some graphical representation of micrometer to nanometer. Okay. Now, concept of functional element of MEMS means minim, miniatures, structures, sensors, actuator. Now, concept of MEM means made up of component between 1 to 100 micrometer in size. Okay. Device vary from below 1 micron up to several nanometer. Functional element of MEMS are uh, miniatures, structures, sensors like this. The main criteria of MEM is that they are at least some element that have mechanical functionality, whether or not they can move. Okay. So this is the some advance and today need or today is the scenario or application of our silicon industry. You heard that the automobile industry needs more semiconductor material or semiconductor material is short, so the automobile industry is in trouble. आपने ये सब सुना होगा कि वो सेमीकंडक्टर की शॉर्टेज है, तो इसलिए कार में डिलीवरी में देर होगी. उसका बेसिक कॉन्सेप्ट अभी डिस्कस होगा, बिकॉज एवरीथिंग इज बेस्ड ऑन सेमीकंडक्टर मटेरियल. मतलब semiconductor material or your sensor is not up to your laptop or mobile or uh, all medical equipments or automobile is based on sensor. This is known as automation. Okay, today is the scenario of automation, because this is the emerging area is now is the IoT. Okay, IoT is nothing but is an application or data processing of thousand sensors. Okay, and our one speaker distributes or give some design of data converters for IoT enabled smart system. Okay, IoT is today is only the processing of thousand or million sensors with the help of software. Okay, now again topic is known as 3D printing. This is the emerging trend. Our very senior professor Satish Kumar Sharma ji from San Diego State University give some basic idea about the high gain antenna, because in our mobile antenna size is minimum but the gain is maximum. This is known as micro strip antenna, and the important point is 3D material printing based antenna and polarization system. This is the new latest topic is covered by the Professor Satish Kumar Sharma ji. And you know ki today area is a some uh, biomedical signal processing or etc. Okay, now concept is what is MAM. Okay, MEMS means physical structure of MEM, देखने में कैसा लगता है. तो MEMS is nothing but is a type of nails, and the size of MEMS is it is the integration of mechanical elements, sensors, actuators and electronics on a common silicon substrate through microfabrication technology. Again, okay, this is the some physical interpretation of MEMS, like IC, like microprocessor, microcontroller, embedded system, DSP processor. But this is the again, this is a very special technology or today market is used by MEMS. Okay, so now MEMS research and development community has demonstrated a number of micro actuators, including micro valves for the control of gas and liquid flow, optical switches and mirror to redirect or modulate light beams, independently control micrometers, array for display, micro resonators for the number of different application, micro pumps to develop positive fluid pressure, micro flap. Okay, now the basic concept is why we use MEMS. The basic fundamental definition of MEM is micro electromechanical system is a process technology used to certain a tiny integrated device or system that combines mechanical and electrical component. Okay, this is some graphical justification of MEMS. Now, this is they are the fabrication by using IC. A batch processing technique can be ranged in sizing for a few micron to millimeter. These devices have to ability to sense, control, and actuate on the micro scale and generate effect on the nano. Now, classification of microsystem technology. There is a three domain. One is the optics, optical communication. Our very valuable speakers from BIT Jhansi, Professor D.K. Srivastava sir, illustrate the some optical fiber communication and some transmission and losses by using some optical communication and some because you know ki our is a optical domain is a very important, and the concept of optics and electronics is known as photonics, yeah, optoelectronics. Okay, now the combination of mechanics or mechanical engineering with optics is known as optomechanics. The combination of electronics and mechanical is known as MEMS. One important emerging area is also known as mechatronics. Okay, these are the emerging area, new technology. Now we know there is some component of MEMS because time is very short. So we cover 4 to 5 hour lecture within the 1 hour is very difficult for me. Okay. The component of MEMS is defined into a four quarterly. One is microsensor, second is micro actuators, microelectronics, and microstructure. For example, microelectronics may be defined as brain that receives, processes, and making decision. Data comes from the microsensor. So, though the total processing domain is defined by the microelectronics. Microsensors is basically defined as consistently gathering data from the environment, pass data to microelectronics for the processing, can monitor mechanical, thermal, biological, or chemical reading. These are the umbrella of applications. Means can monitor mechanical, thermal, biological, and chemical reading. Now, a third domain is micro actuators, act as triggering to active external device. Okay, microelectronics will tell micro actuators to active device. This is a very important point. Okay, Uh, for example, this is the some analogy of relays in an old system. Microstructure, extremely small structure built onto the surface of chip, built right into the silicon of MEMS. These are some definition of component of MEMS. For example, this is some graphical or representation of MEMS. MEM is a combination and some relation or some arrangement of four sensors. One is microsensors, actuator structure, and microelectronics. Okay, this is some definitions. Now, micro or nano word application, physical MEMS or physical sensors. These are the some domain. Micro optics, optical area. This is known as MOEMS, micro optical electromechanical system. Okay, micro probing. Okay, ये micro fluids are the applications. These are the MEMS in the physical words. Okay, now, question is your definition of miniaturizations. Minimum dimension is the trend to manufacture even small mechanical, optical, and electronic product and device. Okay, means MEMS miniaturization is downsizing of sensors and actuators. Okay. So micro machining sensor actuators can handle micro object. Okay, this is the some definition. Third is the microelectronics. It indicate microelectronics control device with sensors and actuators. This is the micro fabric. There are the various fabrication technique. Okay. Now this is some graphical biological application of MEMS, bio cavity lasers of now smart pills implanted in body and automatic drug delivery site of blind lab on chip drug delivery DNA analyzer. Okay, some these are application in marine oil exploration, global weather prediction, monitor water quality of contamination. Like these are the some application in marine. Now, some simulation tool in a MEMS devices or MEMS design tools are available is known as MEMCAD or Converter Waveform from Converter Incorporated USA, MEMS Pro, MEMS SAP from France, and Intelligence from Corning from USA. Now, this is some graphical representation of MEMS operation. You know, this is the application of sensors and actuator design on a single chip. Type of transducer may be capacitive, piezoelectric, and thermal. Okay. The important point is fabrication. This is the MEM operations. This is the step one by one. For example, this is the array. This is known as the schematic diagram of the circuit structure of the sensor. This is the fabrication process. Okay, fabrication process of the sensors. This is the selection diagram of the packaging structure of sensors. This is the photograph of MEM sensor array. Okay, and this E is a symmetric diagram of bending structure. Okay, now, the example of MEMS fabricated device in a automobile airbag sensors. Okay, this is the latest for safety to prevent from the uh, accident. This is depend upon the speed or acceleration of the car. Okay, uh, second is biomems device. Okay, this is known as uh, like inject with DNA, proteins or drugs and then release it back in inkjet printer head. Okay. Now this is the application to uh, internet, smart wearable gadgets or big data or further pursuing from demand of the optical MEM industry, consumer electronics, telecommunication, automotive and semiconductor. Okay, this is the some graphical representation of MEMS, means chemical analysis, environmental, bio, production, delivery, transport, factory, aerospace, information. This is the some MEMS are used in device measuring blood pressure, respiratory disorder, diagnostic equipment, okay, laparoscopic devices. The MEMS system helps doctor to accurately measuring, monitor, and control condition of patient. This is the MEMS accelerometer, MEMS gyroscope. Okay, this is the biomedical applications as pressure sensor, endoscopic pressure sensors, for pacemaker, implanted coronary pressure measurement, some infusion pump sensor, retinal. So these are the very important application of nanotechnology in biomedical application, and this is known as MEMS. Okay, so MEMS means this is a modeling technique with miniature of electronic devices. This is the automobile application of MEMS. You know, today a mobile is covered with all sensors, a tire, air pressure sensors, air bag sensors, electronic stability. Okay, you know, the important point is that the vehicle is totally automated. Okay, so this is automation is with respect to speed and with respect to safety. Okay. Now you know if MEMS, the importance of smartphone, tablet, cameras, gaming devices, and many other electronic device having MEMS technology inside the system. This is the today because no, you know, smartwatch, smartphone, is camera, gaming devices, all are having the size is minimum and application is maximum. Okay, so MEM devices are IC comfortable and so their performance is very good. These are the advantage of MEMS. Miniature has got three folded advantage: smaller size, roughness, power consumption is low. Okay, MEMS are the interdisciplinary research today need. Okay, mass electromechanical automation and robotics, IoT. Okay, machine learning, 3D printing. These all are the emerging areas with nanotechnology. Interdisciplinary team integrate multiple disciplines is the best tool. Now, at again, a physical advantage, cheaper and alternative area is very small, speed is lower, power consumption is low, actuation energy, low heating power. Okay, so now the some disadvantage means fabrication process is tough. So imperfect fabrication techniques is increase the cost of fabrication and difficult to design on micro scale because the some sensor actuators maybe design in nanotechnology or in microtechnology is tough. Okay, these are some introduction of MEMS. Okay. Now, this is some overview. Now, we start with some technology development. Some says ki this is the some VLSI means very large scale integration, means this is depend upon the transistor density. Transistor density means number of transistor per chip. So this is small SSI, MSI, LSI, VLSI, and today is LSI. Okay. So this is the number of gate 10 to 100, 100 to 1000, 1000 to 10,000. Now this is some area uh, or feature size development in CMOS technology from 1980 to 2020-22. In 2022 to 22, now we are using a 16 nanometer device. Okay. So, reducing the feature size means technology size will increase the packing density. Packing density means more and more module can be accommodated on a single chip, increase number of component. The advantage of this low voltage design, because voltage is reduced from volt to millivolt. Okay. So when the voltage is reduced, the power consumption is also reduced. Speed is high. Okay, less delay because the significant reduction by interconnection length. So because we reduce the parasitic capacitance is also is reduced by some simulation software. So lesser area means less number of component, compactness, significant cost time. This is the some high integration means system on chip design, layout minimum, compact and portable devices, integration area of circuit. Now this is the additional is one of the fundamental arithmetic operation is it is used extensively in many VLSI circuit. Okay, this is known as adder. Adder is a very important block is used in a ALU. Okay, now, low power, high performance, as I said, is a great interest in signal processing, ALU hardware design. Now, this is the CMOS logic family, and the classification of CMOS logic family is based on performance parameter in terms of fan in, fan out, noise margin, number of transistor. Okay, this is logic families, not a device family. Maybe RTL, resistor transistor logic, diode transistor logic, transistor logic, MOS, ECL, and BiCMOS. These are the some classification of logic family, or this is known as this classification of IC. Okay, digital IC. Now, this is the CMOS design family. This is the some modification in CMOS is again we use pass transistor logic, complementary pass transistor logic, transmission gate. This is the pseudo CMOS technology, differential cascode. These are the different various CMOS technologies used based on some delay, power, and optimization parameters, number of transistor. Again, CMOS is classified into a dynamic again classified as domino. Okay, these are the families. Now, these are the research issue and objective. I think my time is over, and instead of 124 slide, we have completed only 14 slide. And I think this is the second last slide. And now design, research, and objective is the important point. Integration of digital signal into CMOS. Okay. Now delay is minimum, high speed. Again, no. When the technology is reduced, so some leakage current and some concept is used because current is increased. Okay. Our some Dr. Sanjeev Rai from MNIT Allahabad deliver a lecture on recent train in VLSI design with leakage control and low power design issues. Okay, so delays, minimum power consumption is also low. Capable to operate under the minimum supply voltage is 1 volt. Means CMOS scaling is another issue. Okay. Now allow almost wheel to wheel input and output operation. This is one graphical representation of supply voltage versus threshold voltage. Okay. Now this design layout is shrinking faster and faster because we move from micrometer to nanometer. Okay, this is the some objective. Okay, integration of digital signal into the CMOS. This is a low power delay product. This is again, this is the power, maybe classified as dynamic power, static power, switching power, and okay, dynamic power means charging and discharging of capacitors or short circuit current, leakage current. This is the some mathematical formula. Ki power is depend upon the VDD frequency of the circuit. Okay, now capacitance and some parameter alpha. Now this is the dynamic power. This formula is defined as this some example. This is the some graphical representation. Okay, this is the principle of power. Uh, तो I feel कि this is time is over. यतेन जी,
Yes, sir.
क्योंकि आपने मुझे 4 घंटे की बजाय 1 घंटा
जी
दिया.
सर, जी सर,
Do we have?
जी सर.
मैं 124 स्लाइड में से केवल 15-16 स्लाइड ही पढ़ पाया.
Sorry, sir, for the time constraints.
But it was a very nice session, sir, that you discuss about the MEMS also. You have also discussed about the dynamic MOS and static CMOS, dynamic CMOS. You showed the difference also. Sir, it was enough, sir. That was. You have covered most of the topics within
नहीं,
the-
अभी तो एक्चुअल में नहीं, यतेन जी एक एक स्लाइड के अंदर 20-20 स्लाइड है.
Yes,
जो
sir.
बिल्कुल एक फंडामेंटल आजकल मैम्स बहुत ही इम्पोर्टेंट है.
Yes, sir. I heard that you are discussing about the MEMS also.
क्योंकि आपका जो आप ये सुनने होंगे कि सेमीकंडक्टर की शॉर्टेज हो गई है, आपकी जो ऑटोमोबाइल इंडस्ट्री है वो मतलब बहुत मतलब परेशान है, या लैपटॉप है. सेमीकंडक्टर केवल लैपटॉप और मोबाइल फोन के लिए नहीं है, वो
जी,
आपके, क्योंकि फुल्ली ऑटोमेशन इज यूज इन ए ऑटोमोबाइल इंडस्ट्री. अब
जी.
तो आपका जितने भी सेंसर्स हैं, जितने भी
जी,
एक्चुएटर्स हैं, सब
जी,
आपके ऑटोमोबाइल इंडस्ट्री में हैं.
Sorry, sir, for the time delay or for time constraint. We will definitely try in future to listen you the entire.
हाँ नहीं, आपको आपने मुझे 2 सेशन देने को बोला था, मुझे लास्ट में आपने केवल एक समरी सेशन
Actually,
में
sir, that
कन्वर्ट
is
कर
just
दिया.
because of the validatory function. You know it, sir, very well. We want you to be there in that case.
चलिए ठीक है. ओके, थैंक यू.
Thank you, sir. Dear participants, if you have any query, then please feel free to ask.
Sir, given the short span, you explained the basics of MEMS. It is very useful for us. We got clear idea about the basics of MEMS. Sir. Thank you.
चलिए ठीक है.
Okay. A very good afternoon to all the dignitaries and dear participants. On behalf of Electronics Engineering Department of IERT and entire fraternity of the Institute, I, Jiten Kumar Shukla, Assistant Professor, Electronics Engineering Department of IERT, deem it a great honor and privilege to summarize this session and to propose a vote of thanks for this inspiring session delivered by Professor Subodh Wariya, sir. I use the word inspiring for this session because the way sir started and progresses in his talk is truly inspirational and motivational for us, especially in a limited time frame. First and foremost, we Electronics Engineering Department of IERT Prayagraj would like to express our deep sense of gratitude to Professor Subodh Wariya sir for this enlightening session. During this session, he emphasizes on various basics and advanced concept of advanced digital VLSI design chips. He emphasizes on a power delay product, fan in, fan out, delay, speed, noise margin, and different various parameters that affect the performance of any VLSI circuits and chips. At last, he explained and highlighted the importance of micro electromechanical systems and its definition, importance, and application in detail. He also explained the development in feature size of CMOS technology, low power design, and he also explained the research issues and objectives semiconductor devices in modeling. we understand we have a limited time frame, so sir cannot express the entire information, cannot share entire information with us. So we as an organizing team do not have enough words to express our gratefulness to Professor Subodh Wariya sir for delivering this session with a limited time constraint. Thank you very much, sir. We electronics department of IERT would also express our heartfelt thank you to Director IERT, Dr. Bimal Misra sir, for his consistent guidance, support, and suggestion for making each session successful. B Electronics Engineering Department of IERT remains thankful to all participants who joined this session to make it successful. I hope you all are benefited from this session. Once again, thank you all for the support during entire FDP program. Thank you. Thank you very much.